Hello all. Today we discuss about de-Broglie wavelength of an electron and discuss the different types of problem related to wave properties of a particle. Okay. So first of all, we determine de-Broglie wavelength. So our first topic in this class, find de-Broglie wavelength, that is lambda of an electron. Okay. So this is our first derivation. Consider let v, small v, the velocity acquired by the electron when it is accelerated through the potential difference, capital V. So this is the velocity of the electron when it is accelerated through potential difference, capital V. Okay. Now what is work done? So work done is basically E into capital V by the electron. Now kinetic energy gained by the electron is equals to half mv square. Okay. Sorry, this is small v, velocity. Now this kinetic energy half mv square is equals to capital V into E, that is potential into charge of the electron. So here we get the formula V equals to 2VE divided by m, that is the velocity of the electron is dependent on the potential difference, charge of the electron and mass of the electron. Now what is the wavelength? Wavelength is equals to h by p. So here p is equals to m into v. So here put the value. So therefore this is the mathematical relationship of the wavelength of the electron, de-Broglie wavelength for electron, and this is for the non-relativistic case. Non-relativistic case means the particle do not equal to the speed of light. The particle velocity is do not equal to the speed of light, and it is always less than the speed of light. Okay. So this is our first problem. Now we calculate some parameters related to these mathematical equations. Now E is basically 1.6 into 10 to the power minus 19 coulomb. M is the mass of the electron, which is 9.11 into 10 to the power minus 1, 10 to the power minus 31 kg. And Planck constant equal to 6.62 into 10 to the power minus 34 joule second. Okay. So now if we put this value here, so we get approximately 12.26 into 10 to the power minus 10 divided by root over capital V. This is our unit of meter. Okay. So now if we expressed in Armstrong unit, so now this is equals to root over 150 by V Armstrong. This is lambda. Okay, this is lambda, that is wavelength. Now if V equal to 100 volt, potential difference, then lambda equals to 1.266 Armstrong. Okay. Now when V equal to 200 volt, the lambda equals to 0.867 Armstrong. So for different voltages there are different values of lambda are created. For 300 volt we put here 0.338 Armstrong. For 400 volt, for 12,000 volt, or it is known as 10 kV, 12 kV, the wavelength is 0.1119 Armstrong. Okay, so with these are various types of problem related to the de-Broglie wavelength. Okay, now our next topic is that our next topic is to derive the phase velocity and the group velocity expression. So first of all, we discuss about the phase velocity. So what topic is phase velocity? It is very important for motion of the wave particle. So now it is the phase relationship of this particle that observed as a wave and the velocity with which the plane of equal phase travel through the medium is known as phase velocity, or also known as wave velocity, because every particle begins its vibration, okay, and a little later than its predecessor, and there is a progressive change of phase as we travel from one particle to the next. So it is the phase relationship of these particles that we observe as a wave and the velocity with which the plane of equal phase travels through the medium is known as a phase velocity or wave velocity. Generally, phase velocity is expressed by the expression Vp is equals to nu into lambda, where nu is the frequency, lambda is the wavelength, and we know that omega equals to 2 pi nu, and from here nu equal to omega by 2 pi. So we know that propagation constant k is equals to 2 pi by lambda. So from here lambda equals to 2 pi by k. Okay, so from here Vp equals to nu lambda, that means this is nu equal to omega by 2 pi and lambda equal to 2 pi by k. So basically Vp is also known as omega by k. So this phase velocity is also expressed by this expression omega by k. Okay, so now according to the quantum theory, you know that E is equals to h nu, energy equal to Planck constant into frequency. So here nu is equals to E by h. So we also know that from the de-Broglie relationship, P equal to h by lambda. Therefore lambda equals to h by p. So now Vp is equals to E by h, because from using the help of equation 1, from this equation 1 we know that Vp is equals to nu lambda. So just putting the value of first of nu. What is the value of nu? This is E by h, and then lambda, what is lambda? H by p. So this is h by p. Okay, so we getting the mathematical relationship Vp is equals to energy by momentum. So this relation also holds true for in the case of de-Broglie wave associated with a moving particle. So now we discuss about de-Broglie phase velocity exceed the velocity of light. So now for the non-relativistic case, for a particle of mass m moving with a velocity v, their total energy is equals to E equals to mc square. We already know that for a relativistic case, and momentum p equals to m into v. Okay, so now their phase velocity is equals to E by p, energy by momentum, that is mc square by mv, that is c square by v. So this is a special case for the non-relativistic particle. So you know that as v less than c square, the phase velocity of the associated wave is always greater than c, the velocity of the light in a vacuum. Okay, this is very important. Now in a relativistic case, for a de-Broglie wave associated with a moving particle of rest mass m0 and momentum p, therefore the total energy is m0, therefore the total energy E is equals to m0 square c to the power 4 plus p square c square whole to the power half. Therefore Vp is equals to, we know that E by p. Therefore this expression also written by this mathematical relationship p square c square to the power half, and in this bracket this is p. Okay, sorry, this is p square, because in the power there is a half is present, the power value is half. So now from the some mathematical derivation we common the c term. So from here m0 square c square by p square is equals to the plus 1 to the power half. Therefore again this is c m0 square c square lambda square by a square, because p equal to h by lambda from de-Broglie, plus 1 whole to the power half. So now in this term m0 square c square lambda square by a square is always positive quantity for a non-zero values of m0 or lambda. The phase velocity of the associated wave is always greater than the velocity of light in a vacuum, but according to the theory of relativity, it is not possible that the velocity of the matter wave be equal to or greater than the velocity of light. Okay, so this is the concept of phase velocity. Then phase velocity in a non-relativistic case, we study the de-Broglie phase velocity in the non-relativistic case and then relativistic case. Okay, so now we discuss about the another velocity term is known as group velocity. It is also very important. Group velocity is denoted by v of g suffix. First of all, what is a group velocity? The velocity with which the slowly varying envelope of the modulated pattern due to a group of waves. So that's why here envelope and modulated pattern, these words are coming. I again repeat, the velocity with which the slowly varying envelope of the modulated pattern due to a group of waves travel in a medium is known as the group velocity. Okay, so for the group velocity there are group of waves. So just for simplicity we consider first wave is expressed as a cos omega 1t minus k 1t, where this is the frequency and k is the wave vector, and the second wave is given by a cos omega 2t minus k 2x. Okay, so they are different frequency and different phase vector, different wave vector. Okay, so here k equal to 2 pi by lambda, omega equal to 2 pi nu. So now superimpose these two waves from y1 plus y2. So therefore just a simple trigonometric relationship, and after trigonometric relationship, that is apply the cos a sin b, cos a plus cos b formula, we get, student, do it yourself, omega t minus k. I just write here the final mathematical relationship. This is kx by 2, this is k, okay, and this is x, this is by 2. Okay, now this is y. So this delta omega, basically the difference of omega 1 minus omega 2, and here omega equals to omega plus omega 2 by 2, k is equals to k1 plus k2 by 2. I just denote here the every term, and delta k is equals to k1 minus, yes, k2. Okay, so just come here that now is a superimpose of this two waveform. So now in the group velocity we see that there is an two term, one is 2a cos omega t and another is 2 cos delta omega. So therefore for this second wave, this frequency is delta omega by 2 and propagation constant delta k by 2, and the velocity, therefore the velocity is del omega by del k, change of frequency by change of propagation constant. So the modulated wave is just to look like that. So the group of wave, so here this is a modulated wave. Okay, so that's the group velocity is, and this amplitude equal to 2a. So this is the 2a intensity of the amplitude of this waveform. So now here Vg equal to delta omega by delta k is also known as group velocity term. So now if we here Vg equals to delta omega means del of, that means here is also expressed by this expression delta omega by delta k. So omega equal to 2 pi mean 2 pi nu, therefore 2 pi del nu. So delta k equal to 2 pi by lambda, therefore this is 2 pi delta 1 by lambda. So therefore this is minus lambda square del nu by del lambda. Okay, this is delta, this is known as Vg. So now we know that from the phase velocity relationship that Vp equals to omega by k, therefore omega equals to Vp into, sorry, this is Vp, sorry, just a minute, this is Vp, this is Vp into k. Okay, so therefore Vg equals to d omega by dk. That's why it is d of omega means k of Vp by dk. So if we derive derivative this term, so Vg equals to first Vp, because uv formula apply, k d Vp by dk. Okay, so now k equal to 2 pi by lambda, we don't know that k equal to 2 pi by lambda. So what is the value of dk? Dk means minus 2 pi by lambda square into d lambda. So now next k by dk, just here we express this term by this. Okay, so putting this value of Vg equals to Vp, so putting this value here, so minus lambda dVp by d lambda. So this is the relationship between phase velocity and group velocity, and it is show that the phase velocity and this term is minus from the phase velocity, which is equal to the group velocity of the particle travels from for any medium. Okay, is the concept of group velocity concept in a wave properties of a particle. Okay, so this is the concept of first of phase velocity and then group velocity, and this is the first in the first slide we discuss about the de-Broglie wavelength of electron. Different types of mathematical equation are done here, and then we discuss about the concept of phase velocity and group velocity.